Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. This is simpler, practical use of machine learning algorithms in R. So, in this video, we're going to do our data preparation. And our goal for this video, our goal for this chapter, if you will, is that we were going to take, let me go ahead and move over to RStudio. We're going to use the Vietnam Eye data set, and what we want to do is we want to be able to predict how many days a person is going to be sick based on the independent variables that are available for us. So what we're going to do here is, again, we're using ElasticNet regression to try to figure this out. So of course you're going to want to run your packages. So we're using the EGDAT, CorePlot, Caret, and GLMNet. EGDAT is where our data set comes from. CorePlot is for visualization. Caret is going to be for our grid control and other things that we need to do, especially like the cross validation that we're going to discuss in a future video. And GLMNet, that is where the lasso regression function comes from. So just press Control Enter to load these, set our seeds so we get consistent results. And now we're going to load our data set, and we're going to take a look at our data set by running the code in line 5. And so you can see right here that we have 27,000 observations. That's very large, and 12 variables. Here are all the variables. One variable is a factor variable. So as you know from chapters 4 and chapter 3, we will have to deal with that using some techniques that we're going to use in a few moments. The rest of them are all numerical. And the last one right here, the commune, this isn't really useful. It's just kind of an ID number. So we're going to have to remove that. So here we go. In line 8 and 9, we have our visualizations here. Now notice how in the code we're removing variable number 4. And why are we doing that? It's very simple. If you count from the top, Parvis, log of the expenses, age is 3, sex is number 4. So since sex is a factor variable, we have to remove that when we want to do our correlational plot. Otherwise, we will get an error message. So that's why we have the brackets here. The brackets for subsetting. We've done this in several videos. This is nothing new here. So I'm going to press Control Enter, and now I'm going to display my plot by using the CorePlot.mix function from the CorePlot package. So go ahead and Control Enter, and you can see it right here. Let me make it a little bit bigger for you. Ooh. Okay, so you can see when the numbers are very faint, it means that it's a very weak relationship. So most of the time we're looking pretty good here. There are no serious correlations. Of course, you know, to be thorough, we will make histograms and all those other things like that to really assess it. You know, look at the standard deviations and the means, maybe look at some quartile plots for outliers. But again, we're just trying to focus on using the algorithms in these videos. But in general, it looks like, at least just from examining this for a few moments, we don't have any major problems with correlations on the univariate level, you know, or on that level where it might be a concern. So we're going to go ahead now and go back to the regular video here, regular view. Now, in line 12 here, we start dealing with how to prepare our data. So the first thing we have to do is in line 12, we remove the commune variable because that's not really giving us any information that'll help to strengthen our model. So we just want to null it out, and so empty it out like so. And now this thing in line 13, this is for practical reasons. And again, you probably would never do this in a real application of such an algorithm as ElasticNet. But we're only going to use the first 1,000 samples from the Vietnam Eye data set, because with the type of cross-validation that we're using, leave one out cross-validation, that type of validation is very computationally intensive. And so if we want to sit here for 2-3 minutes, we could do all 27,000. But since we're just trying to practice an experiment, I just want to do the first 1,000 samples. Again, you would never probably do this in a real context. Now, lines 14, 15, and 16, this is the same code that you've seen in other places. That what we're doing here is we're just trying to separate our data set into a training set and a test set. It's the same code. So I have my index here, IND. I use the sample function. 1 to 2 are the numbers. The number of rows I want is going to come from the Vietnam Eye reduce data set. So that's 1,000 with replacement. And the probability is 70-30. So 70% of the rows will be 1s. 30% of the rows will be 2s. So we've done this before. And then for my training set, I'm going to map my index. Wherever there's a 1 at, I'm going to map it onto my Vietnam iReduce and give a row that's a 1. Or I'm sorry, make a test set that has a training set where every row that is mapped as a 1 in Vietnam iReduce is going to be in the training set. And then we do for the 2s, there's going to be in the test set. This is all, we've done this several times. Now, this stuff in lines 19 and 20, 18 to 20, if you will, this is a little bit new. And so what's happening here is that in using the ElasticNet function, the algorithm there, instead of having one parameter to set, hyperparameter, which is always lambda, we now have two hyperparameters that we have to set, the alpha and the lambda. Now this complicates things because before, in the prior videos, the computer would just run 100 different models and then set the lambda to whatever was most efficient. But now we have to set two we call it two hyperparameters at the same time. And so because of that, we have to set up a grid where no longer does the computer kind of decide how to adjust the hyperparameter, but we have to try to give it a certain range of values that it needs to deal with itself. So having said that, we need to create an object called grid. And then after that, we use the expand.grid function, and we want to set in here the .alpha. So we're going to have it set by a sequence from 0 to 1 by 0.5. So it'll have 0 probably, 0.5, and 1. So basically 3 models, if you will. And then for the lambda, if you look over here, whoa, you can see we go from 0 to 0.2 by 1. So it'll probably be 0, 0.1, 0.2. Again, we are just trying to demonstrate how to do this. You would normally probably have more models that you would experiment with, but again, it takes a lot of time, at least on the computer that I'm using, to try to process all this. And so what's going to happen here is that let's go ahead and run this, and then I'm going to show you what it looks like. So you can see these are the models we have. So we have 9 models altogether that we're going to run. The first model, let me make this nice and beautiful for you. Nice and beautiful for you. The first model right here is going to have an alpha set to 0 and a lambda set to 0. The next one will have an alpha set to 0.5 and a lambda set to 0. The third one will have an alpha set to 1.0 and a lambda set to 0, etc., all the way down. And so through doing this, we have 9 models that we have to make, because we have to set these two hyperparameters simultaneously. That's the challenge that we are facing there. Okay, so we've done that, and we're almost done with our preparation here. The last thing that we have to do before we start to develop our model, which will be in the next video, is set up our control. Now this will be very, very valuable when you actually see the code for making the model, but that's going to be the next video. But the control here is kind of telling the computer, okay, how are we going to deal with the validation of this? And the reason we have to deal with the validation is because we are using all these different models at the same time, and also the cross-validation is going to help to check our results, if you will. The beauty of cross-validation is that it helps you through resampling from your current data set to develop the appropriateness or the validity of your model in another context. And so through doing cross-validation, you are able to check if your model will work with other data sets. And so the style of cross-validation that we're using is leave one out cross-validation, which means that it uses all of the data set except for one, -1, so n -1 to run the data set, and then it checks it against the one that was left out. And so, since we have 1,000 samples, it's going to be cross-validating, almost 1,000 times basically. And again, because this is computationally, expensive, it's another reason why we reduced our sample size to only 1,000, because it's going to check. It's going to take 1 through 999, check. Then it'll take 1, and then it'll skip. It'll take 1, and then it'll take, it'll start at 2 and go all the way up to 999. And then it'll start at 3, and then also take 1 and go all the way up to 999, etc. Going slowly through every single possibility, and it'll give you the average of the results. And so by doing this, you can have more confidence in the actual results that you get. But for now, we're just going to press Control Enter, and then I'll just show you what it looks like. It's not that exciting. It's just, this is all it prints out here. The different rules for the cross-validation. That's all it's for the leave one out cross validation. That's what's happening there. And so not that exciting. But the good news is that we have prepared our data. We have, let me just show you what we've done. We have done our visualization. We know if there's any high correlations or not. We split our data. We also have set up our grid and our cross validation. Now we do need to deal with also some of the the factor variables. We're not going to deal with that just yet. But for now, we are done with setting up our model and dealing with the various problems that we might encounter when we make our model. But like I told you, we will deal with the factor variables in a second. So in this video, we dealt with our data preparation. I explained to you the different parts. What's really new here and what's unique for us is this idea of developing a grid. By developing a grid, you're able to set up multiple models that R is able to test based on however you set your hyperparameters. And again, this allows the computer to focus on the calculation and not trying to randomly pick appropriate hyperparameters. When you go beyond one hyperparameter, the computer needs help often, R needs help often to deal with that. And the last thing that we talked about was, of course, dealing with cross-validation, which helps you to deal with the appropriateness of your model in another context besides just the data set that you're working with right now. So I hope this video was useful for you and that you're able to understand, and we're going to apply this in a few moments. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler Using Machine Learning Algorithms in R. Thank you.